And thank you to the organisers for giving us this opportunity to present to you this morning, and thank you for everyone for joining us. The observant amongst you might have noticed that I'm not Kevin Williams, and that's because unfortunately Kevin Williams has come down with COVID yesterday, and so he's not able to join us, which is a real shame. What he has been able to do though for us is pre-record the presentation. I totally appreciate that is not the same as him being here in person, and does mean that he's not going to be here to answer any questions for you. But if you would like to come to the stand, we're in the Britannia Suite number 4, and we'd be happy to take your details and any questions you've got, and I'm sure he'll be better soon and able to come and see you in person. We're more than happy to arrange that for you, if that's the case. So without any ado, let me start.
It can be argued that the Health and Safety at Work Act 1974 should have been named the Safety and Health at Work Act. The reason being is over the last few decades, much of industry's attention has been on reducing the number of work-related deaths. The latest HSE figures in 2020-21 suggest that 142 people went to work and didn't return. It can be argued whether that figure is tolerable or acceptable, but it is certainly much, much less than the figures that were around prior to the Health and Safety at Work Act. Each year, it's estimated that 12,000 people are dying of lung disease deaths linked to past exposures at work. I don't think it's tolerable or acceptable with that high figure. More worryingly, it's estimated that 17,000 people each year are being diagnosed with breathing or lung problems caused or made worse by their work each year. So we know that figure is going to increase over the foreseeable future. The latest statistics have also introduced a number of statistics around COVID-19. The number of COVID-19 cases reported, and that's RIDDOR reported, is 32,000 due to exposure at work. So why do we think the number of lung disease deaths each year is so high? Well, recent HSE survey estimates that 5.5 million employees in over 220,000 industries are at risk. It's estimated that 50% of the respiratory protective equipment does not offer the correct level of assumed protection. It's also suggested that the respiratory protective equipment has not been correctly selected. Finally, users have not been adequately trained or face-fit tested, if applicable. It's really important that whenever respiratory equipment is needed in the workplace, that a comprehensive respiratory management program is in place. This involves 4 areas. First of all, we have to have a correct selection. So we need to know that that mask is correct for the environment and the hazard. We're far too guilty over the past few years of issuing respiratory protective equipment but not providing adequate and suitable training or instruction to make sure that that's fitting the people and people know how to wear that correctly. Some respiratory equipment also requires maintenance. This is a great big hole within the respiratory management program for most companies and most industries, but heavily needed to maintain, from a manufacturer's point of view, the efficiency of the equipment. Finally, for any tight-fitting facepiece, it's a requirement to be face-fit tested, and that's to ensure that there's no gaps or breaks in the seal to make sure those small particulates or gases do not bypass the filter material on the respiratory equipment and get into our lungs. The first phase of a respiratory management program is to make sure we've got the correct selection of respiratory equipment. It needs to be adequate and suitable. By adequate, we mean it is right for the hazard and reduces exposure to the level required to protect the wearer's health. By suitable, we mean that the respiratory equipment is right for the wearer, the task and environment, such that the wearer can work freely and without additional risks due to it. It's really important that we know what the hazard is in selecting the correct equipment, and we also need to know what the concentration being exposed to is. This helps us determine filters, styles and types of masks. The best way to do this, find out the concentration, is by doing individual air monitoring, but this isn't always possible, and an informed decision sometimes needs to be made. The task that we deal with is also really important. It could be a very manual task, or it could be a light duty task, and that can determine on the best type of equipment to use. The time is really important. If we are wearing a mask more than 1 hour continuously, it's considered good practice to examine a powered respirator or a power assisted respirator, because that will give better wear comfort and less likelihood of the mask slipping and becoming ineffective. Again, in all industries, this might not be practicable, but it should be considered. The environment is really important as well in the selection piece. So that could be a confined space where certain respirators might not be able to be worn. It could be a hot and humid atmosphere where a tight-fitting filter respirator might be really uncomfortable for the wearer, and a powered or airline apparatus might be more suitable. The final thing, and one of the ones that's mostly ignored in selection within industry, is the person. It's really important that the mask fits the individual and they're going to get a full protection. That takes into consideration the face shape, size, facial hair, any scars, anything which might cause an ineffective seal on the face piece. The second phase of a respiratory management program is the training. Training can be covered in a document called the HSG 53, which is the selection, use and maintenance of respiratory protective equipment. In that, it states that all people involved in the wearing, storage and maintenance must be trained. The document is quite concise in what should be included in a training instruction. It should include at least the following areas. Why is respiratory protective equipment needed? What are the hazards, the risks and effects of exposure? What respiratory equipment is being provided and how does it work? How do you wear and check it correctly? Fit checking before use. What maintenance is required and when? And where and how do you clean and store it? Obviously, within the healthcare industry, certain criteria might also need to be adapted and covered in the training. The vast majority of respiratory protection within the healthcare industry is classed as filtering face pieces, commonly known as disposables. For these, there's no maintenance required, as they are classed as pretty much one-use only masks and are discarded after each use. However, there are a number of reusable respirators within the healthcare sector. With these, it's important that there's a maintenance program and that's recorded on a regular basis. Under the control of substances hazardous to health, any respirator which is kept longer than 28 days must be formally inspected and recorded by a competent person. Those records must be kept for a minimum of 5 years. The reason for this is to make sure that there's no damage or defects on the respirators which are being used continuously, and things like filters, straps, valves and consumable parts are being replaced accordingly by a competent person. This is the one area that most people fall down, or most companies fall down on a respiratory management program. The final part of a respiratory management program is that of face fit testing. Face fit testing became a requirement in 2002, and it's a method for checking that a tight-fitting face piece matches a person's facial features and seals adequately. Over the past 2 years, this part of the respiratory management program has really come to the forefront because a lot of masks being worn by individuals just do not offer the protection because they do not give a secure fit on the individual's face. Face fit testing ensures incorrectly fitting face pieces are not selected for use. The performance of tight-fitting respiratory depends on a good seal, and it's really, really important to make you aware that that means no facial hair within the seal of the face piece. By no facial hair, the HSE sort of description of that is a wet shave no more than 8 hours prior to the start of a shift. So clippers, 1 or 2 day stubble in most cases, adversely affects the performance levels of that mask and should not be used. Face fit testing also highlights that one particular make or size is unlikely to fit everyone. And again, throughout the healthcare industry over the last couple of years, it's really emphasised that some masks do not fit everybody, and you'll probably have in your own areas several different types of masks to make sure there's one that fits each person. And face fit testing should be done on initial selection of the respiratory equipment. The latest guidance on face fit testing can be found with the HSE document INDG 479. That has recently replaced the HSE OC 282-28. The INDG 479 is also accompanied by 3 further documents published by the British Safety Industry Federation. And these are in 3 areas: for qualitative face fit testing, quantitative face fit testing using an ambient particle counting machine, and quantitative face fit testing using controlled negative pressure. Further information on these and free downloads can be found on the website www.fittofit.org/resources. The reason for the removal of the OC 282-28 and replacing it with the INDG 479 was to make it far more easier, as the process was getting quite complicated and the documents quite wordy and lengthy. So the INDG 479 now has been really stripped back, and that's written by the HSE, and that explains why face fit testing is required and why it is important. The accompanying companions written by the BSIF explain how to carry out the face fit testing. It's important to note that within the BSIF guidance, it recommends that face fit testing is now adopted every 2 years. It gives further information and links to facial hair and the performance of facial hair affecting the seal through a further document called RR1052, and it also gives more clear guidance on qualitative procedures. It's worth noting that following this guidance is not compulsory, and a company is free to take other actions to comply with the requirements of the law. However, following guidelines will normally show compliance to the law. In layman's terms, that means that if you do not carry out a face fit test with one of these 3 methods, if, heaven forbid, a court case was brought about, you would need to show that you've at least met the best practice contained in the Fit to Fit guidance or superseded it. The face masks that require face fit testing are classed as tight fitting. So this includes all disposables. It does not include type 2Rs commonly used as preventative masks within the healthcare industry, but anything which is classed as filtering face piece, which relies on a tight seal over the nose and underneath the chin, will require a fit test. It will also require a fit test on half masks with filters on or full face masks. If you do have full face masks linked to powered respirators or airline apparatus, then they also require a face fit test. The only forms of respiratory equipment which are excluded from requiring face fit testing are loose fitting face pieces. That includes visors, head tops or helmets. As per the pictures shown, these do not rely on a tight fitting seal. They require a power supply, normally through a battery pack or an airline, which provides a flow of air into the mask, giving the assumed protection. These are the only types of head tops which are suitable for people with facial hair, affecting the seal of the face mask. These are not always practicable in the workplace and need a higher level of maintenance to ensure their performance. There are two types of face fit testing which you may well be aware of over the past 2 years. The first method, which is the picture on the left, is qualitative. Qualitative face fit testing is a subjective method which relies on the individual being tested to tell you if the mask fits them or not. Loosely, the test requires the individual to wear a face piece, including other PPE that might be worn during their day's work, inside the hood, whilst a test solution is sprayed inside the hood. The individual will be asked to carry out several exercises lasting for 60 seconds each. And that's normal breathing, deep breathing, moving the head from left to right, lifting the head up and down, talking out loud, bending over at the knees, and back to normal breathing. If at any time the individual can taste the solution, it's not a smell, it's a liquid particulate, so it will be a taste, then they would inform the tester and it's deemed that that mask is not fitting the individual. If they cannot taste the solution, then it's assumed that they've achieved a fit factor of 100. This method can have a couple of problems. Some individuals may not want to work in an environment where they need to wear the mask, so they can suggest that they can taste the solution coming in which case it's deemed as a fail and they cannot wear that mask. On the other hand, the individual may feel that their livelihood or their job is at risk and they don't want to upset anybody, or they're really eager to carry on with the work, so they will suggest that they cannot test the test solution when in fact they can. Unfortunately, as a fit tester, it's difficult to know whether anybody is knowingly or mistakenly making an incorrect assumption. The second method is quantitative, and I'm going to concentrate on the quantitative ambient particle counting machine, which is the most common method of quantitative face fit testing throughout industry and throughout healthcare. This method is far less subjective. It relies on a machine counting particles in the atmosphere and inside the face mask through a probe or adapter, and it does a calculation as to how much cleaner the air is inside the face mask compared to outside. Whilst attached to the particle counting machine, the individual will carry out the same exercise as with the qualitative, so that's normal breathing, deep breathing, moving the head from left to right, lifting head up and down, talking out loud, bending over, and back to normal breathing. As an additional test, the individual must carry out a stepping exercise during the quantitative test procedure, and this can either be using a step or a slow marching up and down on the spot. If there is a leak inside the face piece, the machine will pick this up. The pass level we are looking for disposables and half face masks is 100, which means a fit factor of 100, and that is that the air inside the mask is 100 times cleaner inside compared to outside. For full face masks, if applicable, the pass level is 2000, so that's 2000 times cleaner inside compared to outside. This method is far less subjective as the machine does the calculations and identifies any leakages. Downside to this method is the cost of the machine, and also the individual may not be aware of how they've passed the test or not. Anybody who carries out a face fit test should be competent to do so. The competency is outlined within the INDG 479 document and has 16 points that should be adhered to. Another way to show competency is by taking part and being assessed by the BSIF, the British Safety Industry Federation, in their Fit to Fit scheme. This is where an individual will carry an assessment, a written exam and a practical assessment to show their competency in conducting the method of face fit testing that they want to carry out. We at Arco Professional Safety Services are very proud to have the largest mobile team of fit-to-fit accredited testers in the UK, and we've also carried out multiple training courses and assisted healthcare professionals gain their fit-to-fit accreditation through our training and mentoring programme. So as a brief recap on how we may be able to support you going forward, the 4 components of a respiratory management programme are correct selection. We can offer to support the correct selection of RPE based on monitoring reports or extensive knowledge within the industry. We can support you with training colleagues how to wear the masks correctly, understanding the hazards and risks to exposure. We can also carry out training courses and mentoring towards your own in-house face fit testing. If you have reusable masks, we can offer training on the servicing, or we can actually carry out the servicing on those masks for you to make sure we are in compliance with the cost regulations. And we can also carry out face fit testing on all tight fitting face pieces and provide comprehensive reports. And we also have the ability to provide online reporting so that you can see exactly who, when and what has been tested. Once again, I would like to thank you very much for attending this presentation. I'm extremely sorry that I couldn't be there in person to answer questions directly. I do have a couple of colleagues that are present. If you would like to ask any questions or for me to respond by anything via email, please visit our stand, which is stand 4 in the Britannia Suite. Again, thank you very much. Take care